So it says, are the two triangles below similar? And then it says here, it's multiple choice, right? There's A, yes, because the two pairs are of congruent yes, because there are two pairs of congruent corresponding angles. B is no, because there are not two pairs of congruent corresponding angles. Yes, because corresponding sides are proportional. No, because the corresponding sides are not proportional. So look at here. What we're looking here is that we have some sort of we have these two triangles, right? So let me draw these out. And again, this is a geometry question, or it could be a grade 9 kind of problem here. Okay, so we have this side is 14, this side is 10. We have this here is 65, this here is 30. And then we have a smaller one, but I'm not going to draw it to size, obviously, because I don't have space. This here is 7. This here is 30, and this here is 85. Okay, so the first thing we have to do is, so what we're going to do, I'm not going to look at the solution yet, but we're going to say, are these two triangles below similar? So again, take a moment. I'm going to define what similar is before you, and you can take a minute to work out this problem. Again, similar triangles. So first, we have to define what are similar triangles, right? So let's define what are similar triangles first, and then we have to define, okay, what about and if it fits this criteria, right? So again, what are similar triangles in this case? And think back to, again, congruence theorem. Think back to congruent sides and similar sides. What is the definition of similar triangles, right? Similar triangles, again, they are congruent, right? So they are congruent, or the angles here are congruent, so they have the same angles, are congruent, but the side lengths are different in terms of that they're proportional, right? Angles are congruent, so they're the same, and the side lengths are proportional, right? So when we say that they're proportional, we have to say, oh, maybe one side is 2 and the other triangle is like 4 or something like that. So it's a factor of 2 or factor of 3 or factor of 4 or something like that. If it's like twice as big or 3 times as big, the side lengths are proportional, right? Okay, so we have that. That's fine. So can we define? So again, take 30 seconds to think about this problem here. So the trick here is to look at the angles first. So you have 65 and 30, and you have 30 and 85, right? So what I would do first is I would solve for this angle here first, because I have this is 30, this is 85, this here is 30, and this here is 65. Or what you could do is you could solve for this angle here, right? It doesn't matter, because what I want to do, I want to prove my first point here. Are angles congruent here? So I have to prove this here, and then it's this here, right? Okay. So let's do that. So we have this triangle. I'll say this is triangle A. Oh, sorry. This here is triangle A, and this here is triangle B. So in triangle A, again, if I want to find this all the interior angles of a triangle, what I have to do is I have to subtract it by the total, right? So again, angle or triangle A equals, again, it's 180 is the sum of all interior angles in a triangle, right? So 180 degrees minus, and you have 2 degrees here, right? Or actually, no, this is not a triangle A here. Sorry, my notation is bad. I'm going to say that this here is x, okay? Define this as x, and this here is y, okay? So x here, or angle x, would equal 180, right? 180 is the sum of all the interior angles minus, and then I'm going to have to add up these two angles, right? So again, minus 30, and then minus 65, right? So again, because I want to find what this angle here is, right? So I'm going to have to subtract from 180 from both these numbers. So let's do that. So 180 minus 35 minus 65. I'm just going to take out my calculator to do this. So 180 minus 30 minus 65 is going to give me 85 degrees, which means that this here, angle x, is 85 degrees. So I can write here, this is 85. This here is 85 degrees. And then let's look at angle B here. I'm going to solve for angle Y here. So angle Y says that it's also 180 degrees because it's still a triangle. It's minus, again, here is 30 degrees and 85 degrees, right? So 30 minus 85, and I should get 65 degrees in this case here. I'm just going to double check. 180 minus 30 minus 85 is 65 degrees. So I have here angle Y is 65. So now I have to ask myself, are these two triangles congruent in terms of angles? And the answer is yes, right? Because why? I have here 30, 30, 65, 85. I have 30, 65, 85, right? The triangle is just rotated differently, but I have the same angles here, which means my angles are congruent, which is great. Sweet. Angles are congruent, which means that let's see. Oh, this is angles and sides, right? So this angles are congruent, so that's good. And we have to talk about the sides here. Are side lengths proportional? So here I have a length of 14 and a length of 7, right? So again, this here it is proportional, right? Because I can say that this triangle A is double the triangle length of B, right? 14 is double 7, right? 7 times 2 equals 14. So the side lengths are proportional in this case. So in this case, I would say that they are similar triangles because here I would say that yes, because there are two pairs of congruent corresponding angles, because my angles here equal to this are the same angles in A as in B. So I'm going to say that A here is the correct answer, and they have here A is the correct answer as well. Okay, so again, I'm going to walk through the solution with you, and let's see what they wrote here. The students again from Waterloo, University of Waterloo. So it says here in triangle ABC, angle A is 30, 65, and 85 using triangle sum property. So that's what they did here. Again, they solved for 180 minus those two angles. And they did the same thing for this one. The angle Y, I defined it. They solved for 65, which is great. Since two angles of the triangles are the same, therefore by the AA similarity rule. So the angle similarity rule, the two triangles are similar. That's true. Since all sides are not given, therefore there are no side rule that can be applied here. Therefore A is the correct answer. So I like this solution. So I'm going to say a great solution, but I wish you included wish you included the step-by-step math for the triangle sum property. So again, when we talk about the math, it's just the 180 degrees minus the interior angles here. So I wish they included that, but it's totally fine. So I'm going to say the solution here is correct.